Good morning, everybody. Welcome back to lecture number 5. Before we start, let me walk over the homework, give you some quick tips. I will start with question 7. So I'm going to give you verbal tips. I'm not going to write anything. Question 7, you know this is 14 volts, huh? So the current here, you can calculate it. The current here or there, whatever. 14 over 6. Okay? The voltage here is parallel here, so you combine those two resistances. We'll study that today. This is 12. 14 over 12, you can calculate the current here. This 14 over 4, you can calculate the current here. You already know the current here. So you do KCL around this big node, and then you can calculate I, 0. Get it?
So make it smaller.
Make
it smaller.
So voltage, this voltage over this resistance, this voltage, which is 14 over the combination, 8 plus 4 is 12. This voltage over this voltage, you will know this current, you will know this current, you will know this current. You already know this is for amp, and then N equal out, and then you can calculate I over. This is a trick question. So for this question, Vx, you do a KVL around this open loop, okay? So if you put plus or minus, you will have, let's put, this is 6 ohm. Think of Vx as like this, okay? This is 3 ohm. Then you put plus minus, and then you can write V6 ohm, V3 ohm. Means subscript of 6 ohm. And then we do a KVL. Voltage rise or voltage drop? Voltage rise or voltage drop? Voltage rise or voltage drop? Drop. So Vx equals V6 ohm minus V3 ohm. How to get V6 ohm? You need to do, we'll study it today, that you can calculate the current here. How to get V3? You can calculate the current that goes from top to bottom. What is I 6 ohm? It's going to be 18 over 2 plus 6. You'll figure it out yourself. What is I 3 ohm? 18 over 9 plus 3. You do the math, okay? Gave you this is enough hint for the homework.
What do the signs indicate for the...
I told you, if he doesn't give you a sign, you always put the plus sign on the top, the negative at the bottom. And then you assume a direction from that enters the positive, because we love option 1 and option 2.
Yeah, but the negative, how could we do
This
it?
one?
No, yeah.
Yeah, this is the voltage drop across, this is fake point. And that's why I wanted to give you this thing, is we can do a KVL around half a loop. So this is the big loop, right? You can do a KVL around half a loop. So the potential difference between this point and that point is actually V6 minus V3. يعني بالعربي بالعادة هذه ما نحط VX. هو الترك يسألك عن ال VX. إذا ما أعطاك ال VX عادة بيقول لك إيش التيار هنا إيش التيار هنا. You can calculate it easily. 18 over 2 plus 6 هذا التيار هنا. 18 over 9 plus 3. Then Vx, you do a KVL around half a loop. Remember when we did the open circuit example? We did a KVL around open circuit. هذا نفس الشيء. You can do a KVL around half a loop, and then you do this equation. Clear? For the last problem, we probably need until the lecture of today's lecture or tomorrow, but we may do nodal voltage analysis and KVL, so this is a hard problem, but you can solve it. You can solve it. But I wanted to show you these two problems because, so any question?
So this homework is about chapter 1 only, right?
It's only about chapter 1, yeah. Okay. But you can use chapter 2 to solve chapter 1. question about the homework. As you can see, the homework is common between all sections, and the deadline is fair among all sections, okay?
So the last problem, how do I approach it?
By nodal voltage analysis is a good one.
Assume all the voltages, the current is coming out of the node.
No. The last problem?
Yes.
There is many ways of solving it. You can do nodal voltage analysis from chapter 2.
Using chapter 1.
But you can figure out, I can give you some quick tips. If you know this is 32 volt, this is 8 amp, the current here is 32 over 8. Then you can know the voltage here, which is going to be 32 over 8, the current multiplied by 10, you know the voltage here. If you know the voltage here, you know the voltage here, you know the voltage, what do you want? You want to know V2. So you can calculate V2 using a KVL. So you know that you can calculate this current. It's a combination. You need to, I cannot explain it completely, but this is one way of doing it. That's how you start. Get the current here. Okay? And then once you calculate this current, you will say, okay, how can I know this is 32 ohm, I can run another KVL. Maybe he wants V2. So if I know the current here, I can calculate those two voltages. So you need to figure it out. But once we do nodal analysis, you can calculate it another way. So there's many techniques, but this is challenging problem.
Just one question. Does this count as a loop?
This can be a loop, 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 this, the whole thing can be a loop, this can be a loop, this can be a loop.
Okay.
You have different loops. I don't know, I didn't solve this problem yet. I need to sit and try to solve it. But you can see that you can calculate V2 by a KVL. You know I1, and you will know this current. You can do a KCL here. It's a combination.
I have a question.
I think we need to start about the homework.
Yes.
Let's do it later. Okay? We'll go back to the homework if we finish today's material, because today's material is important. Chapter 2. So what we have seen is from chapter 1, trying to solve these problems is a bit, if you get your luck right or not, and it's mechanical, more mechanical. We need a procedure. We need a procedure to do KCL, KVL properly. Okay? So today we'll talk about only resistive circuits in chapter 2. We will cover hopefully today up until at least some of 2.3. We will have resistance in serial and parallel, network analysis by using the series and parallel combinations, voltage divider and current divider rules, nodal voltage analysis, and then we'll cover maybe Thursday mesh current, Thevenin and Norton equivalent, superposition principle, and Wheatstone bridge. So let's start with Ohm's law using this simple circuit, okay? Now, what is the relationship between R1, R2, and R3?
Why are they in series?
Why?
Because they share the same.
The same current. That's one definition. Another definition is R1 and R2, they share a single node alone. R2 and R3, they share a single node alone. In series, it means R1 is also in series with R3. So if we do Ohm's law, the current enters here. Is this a voltage rise or voltage drop? So I'm not going to draw the circuit, but let's begin from here. Rise, V plus. Is this a voltage rise or voltage drop? Drop, minus. V, they call it V1. Minus V2, minus V3. Equals 0, right?
Yes.
So that's a KVL. Now this implies that V equal V1 plus V2 plus V3. Each one of V1, V2, V3 is actually I. What's the I? We call it I here. I times R1 plus I R2 plus I R3, right? Now what I know is I can replace all the three elements by a single R equivalent which we call it IR equivalent, equal to V. So this implies our equivalent is nothing but R1 plus R2 plus R3. Now this formula is applicable to 4, 5, 10, as long as those elements in series. I'm not going to ask you to derive it in the exam, but what I'm going to ask you to do is figure out which elements are in series and which elements are in parallel. So any question about the series combination? Is the concept clear? Parallel, what's the definition of parallel? Multiple elements sharing two nodes. It can be 2, it can be 3, it can be million. So in this example we have 3 elements. And we did a KCL here, which I told you we're zooming in the node. That's why it appears as 2 nodes. So we can do a KCL around this big node. N equal out. What is N? I. What is out? I1 plus I2 plus I3. We know that each I1 we can apply Ohm law, which is clearly, is this option 1? Option 1, option 1. So no negative sign. What is I1? V. This is V here, V here, V here. It's in parallel. V over R1 plus V over R2 plus V over R3. ناخذ العامل المشترك 1 over R1 plus 1 over R2 plus 1 over R3. Now, this is what we call it, and this is equal I. This is what we call it the equivalent parallel combination. How to do this in calculator? Anybody has a calculator? Casio? Yeah. So, this is the camera. You see it? You put 1 over like that. 1 over. I'm going to put it in the camera. كسور مربعات 1 over 5 for example plus 1 over 5 plus maybe 1 over 5. Let's say R is 5. Anybody can see it? I don't want you to waste time in the exam. شوفونها؟ 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 Clear? Clear? بعدين تحط answer. هل هذا هو البارallel combination؟ هذا الريسبريكال. ايش تاخذ؟ الانسر كيف تحطه ماينس؟ ما عندك هنا ماينس 1؟ ايوه هنا في واحده x to the power minus 1. لما تضغط على x minus 1 هو اوريدي بيحط لك الانسر minus 1. الانسر ايش هي؟ 1.66. فهمتوا؟ This calculator, I want you guys to do it now. بمعنى عشان ما تلخبط نفسك, this is the formula. تحسب الريسبريكال أول 1 over R1 plus 1 over R2, بعدين answer سوي لها reciprocal. كذا أسهل طريقة. This way we can solve this example easily now. Find the equivalent. We are looking this way. It means I have to find a single resistor that gives me all of them. 5 plus 5, 20. 20 in parallel with 20. How to do it by a calculator? Again, it's 1 over 20 plus 1 over 20. What's the answer? 2 over 20. صح?
Yes.
This is 1 over R equivalent. It means R equivalent equal 20 over 2 equal 10 ohms. So up until here is 10 ohms. Is the combination, what's the relationship between this combination and R1? Series. So it's going to be 10 plus 10.
20.
So what's the final answer?
20.
Get it?
Yes.
I want you to do it mentally now. Let's do the exercise. What is 2 in parallel with 3 in parallel with 6? Again, do it by the calculator. Give me the reciprocal. قلنا تستخدم بالآلة. I want you to do it now if you have a calculator. So that in the test you have to be efficient. It's clearly 1 over 2 plus 1 over 3 plus 1 over 6. If you do the توحيد المقامات, this 2, this 3, 6, 6, it's going to be 6 over 6 ohm. So R equivalent equal 1 over 1, which is 1 ohm. 1 plus 2? 3. You find the answer?
Yes.
Get it? Let's do this. What's the relationship between 4 and 3? R4 and 3? Parallel. 3 parallel with 6. How much?
1 over 2.
2. دائما it's going to be always less than the combination. Yes, please?
They share a single node, so it's very serious.
No, they do not share a single node. R4, R3, they share a single node, but also R1 is sharing with them. So they're not in series. R2 is sharing a single node with R3 and R4. أكثر من شخص أكثر من اثنين يشاركون node مش series. But they are in parallel. Is R4 in parallel with R1?
No.
Neither. ليش؟ لأنه ما يحقق two definitions حق series الحين. So R4 in parallel with R3 كم طلعناها؟
2.
Are you sure?
Yes.
So R3 parallel with R4 equal 2 ohms. صار عندنا R1, R2, and then we have a single equivalent, we call it R3 parallel with R4. What's the relationship between R3 parallel with R4 and R2? Series. So we have R2 plus R3 parallel with R4. What's the relationship between this and R1?
Series.
Series. Parallel. This combination is in parallel with this.
Yes.
Because they share 2 nodes. So this in parallel with R1. You can do this mathematically in the test. That's another mathematical notation, but I prefer to do it one at a time. So we said R3 and R4 is 1. 1 plus 2 is what? 3, صح?
Yes.
3 parallel with R1? 10. What's 3 parallel with 10? Again, 1 plus 3, 1 over 10 equal
No, right. Sorry.
13.
No.
No.
It's
2
10 not 3.
plus 8, so it's 10. Parallel with 10.
The R equivalent will be 5.
So what is R2? Oh, 8. 8 plus
2.
8 plus 2. We get it up to 2.
Okay, 10. 10 parallel with 10, 5.
Yes.
نص صح. So what's the final answer? 5. I'm going to do this quickly. 25 parallel with 75. And then you do these in parallel. And then you combine them in series. How about this one? R1 in series with R2 because they share a single node alone. The combination is in parallel with R3. And that's the final answer. Is series and parallel clear? The more you solve problems, make sure you solve exercises. All exercises are required. Okay?
I have a question.
Yes, please.
مثلا في المثال أول واحد بي
Yes?
إيه لما طلعناه بارلل بعدين سوينا هذا السيريز صح؟
R4 parallel with R3,
يس
in series with R2, all of them in parallel with R1.
ليه ما قلنا سيريز؟
مين series مع مين؟
all of them سيريز مع
All of them؟ لا ما هم series. Series لما يكون زاوية زي كذا على طول مشبوكين ورا بعض، ما في واحد يخرب عليهم. هنا كل واحد مخرب على الثاني. R2 مخرب على R3 مع R1. فلو تلاحظ النود هذه كم واحد مشترك فيها؟ الإليمنت هذا والإليمنت هذا. تمام؟ لأن هنا بيجي تيار. R2 and R1 are not in series. Because عشان في هنا كوندكتور، هنا في فولتج بيخرب عليهم، في تيار بيدخل من هنا. بس هذه in series لأن ما في شيء مشبوك. أنت اللي حطيت توصيلة هنا خلاص بيدخل عليها تيار. ف R2 and R1 they are not in series. R4, R3 they are in parallel. The combination صار series. تسلسل مع R2. The whole combination parallel مع R1. أنت تبغى تشوف من هنا. You're looking always from left to right.
طيب الكومبينيشن مو حيكون مع R1 series؟
No. Combination will be R2 plus another resistor here. They are going to be in series, but still it's going to be in parallel because it shares this node and that node. يعني لو عندك R1 عندك هذا R2 قلنا هذا R3 parallel with R4 هذول كلهم in parallel with R1 because they share two nodes. Get it? Any question about the exercise? Done with 2.1? Let's try to solve this example. Now we know this trick, we can simplify many circuits, right? For example, this circuit we can simplify it. We can say it's 90 over R1 plus this parallel combination. What is this parallel combination?
20.
So R2 parallel with R3 equal? Do it by the calculator, or you can do it all the way. Inverse. Don't forget the units, put them in brackets. So 20 plus 10 is 30 ohm. So you can simplify the circuit to be 90 volts over R equivalent, which is 30 ohm. So the current will be moving which direction? If he doesn't specify to
From
you,
positive to
try to put your effort that it enters the. It's going to be V over R equivalent, which is 90 over 30. I don't know, 3 amps. Get it? See how we made it simplified? So in the homework, I don't care, even though it talks about chapter 1, but you can simplify and calculate this I. So you can simplify this to be, I told you, 18 over 12 plus 6, 8. So this is the current that enters here. And then the current that enters here is 18 over 9 plus 3. And then you can calculate this voltage, it's going to be the current times 6. You can calculate this voltage, it's going to be the current times 3. And I told you KVL here. Vx equal V6 ohm minus V3 ohm.
I can assign any 2 points in the circuit and measure the voltage, which is the same idea here, right? Like I can assign it between, for example, 6 and 3 from below. Or
Which element you're talking about?
like if I want to measure the voltage difference.
If you want to measure the voltage, the plus is here, the negative is here. Somebody might come in the test, they ask you what's the difference between this voltage here, plus, and the voltage here, negative. Or here, which is 0. You can reverse the polarity, we can put the plus and minus, and the Vx, that if you put plus and minus, there will be negative of that answer. So the question is, if he gives you Vx, keep it as it is. He didn't give you what's the voltage drop across 6 and 3, so you assign it based on the current. So you will say the current here will split here and there. And then the current that goes here is going to be plus minus, plus minus, plus minus, plus minus. And then you do a KVL around half a loop. You can do a KVL here. And then you can calculate the answer. Get it? Again, this question, it takes effort. Try to solve it. But there is a trick to solve it. I didn't solve it. Maybe come to the office hours, we can talk about it. Get it? Come to the office hours. Okay? Let's take a quick break. A couple of announcements. TAs. We have 2 TAs. We share the TAs with the other section of Dr. Ahmed Al-Ahmed. Bother them, okay? Bother them. اشغلوهم. Tamam? It's their job to help you with me. Okay? So they will help you a lot with homework, mainly. Okay? And they will be grading your homework. And maybe the quiz. Major exam 1. This is the date, February 13. Major exam 2, April 12. Let me verify. Could be wrong. Let me verify. This is all set by the department, so yeah, 2, 3, 4, exam 1 is February 13, exam 2, April 12. This one will be on Thursday, one will be on Saturday. Time is 6:30 p.m. بعد المغرب, subject to change the time, but the date is fixed. Any conflict?
Too early.
Huh?
Major one.
Yeah, too early, it is what it is. خلاص? Let's go back. How to solve this problem? R2 parallel with R3 parallel with R4. What's the equivalent answer? Give me, if you don't use a calculator, give me your calculator. It's going to be 1 over 40 plus 1 over 30 plus 1 over 20. And then you take the reciprocal. What's the final answer? 9.2? 3. So we can say our equivalent is R1 plus R2 parallel with R3 parallel with R4, which is going to be 10 plus 9.32.
19.20.
Not 19, 9.
Oh,
It's going to be 9, صح?
yes, yes, I mean the.
Yeah, the equivalent is 19.32 ohm. So the question asks, what is I1? I1 equals 20 over 19.32, which is going to be, I think, 1.04 amp. And then it's very easy. I2 is what? How to calculate I2? KVL.
Yes.
Let's write the KVL. Which loop? The left-hand sided loop. صح? I know this voltage, I know this voltage, I do not know this voltage. How to write the KVL? Who wants to be the guy who walks around the KVL?
We put the voltage up.
You. What's your name? Ahmed. So this is Ahmed. Are you okay to be a KVL guy? This is Ahmed. Now again, I don't care about whatever I see here. I don't care. Voltage rise or voltage drop?
Right.
Put the polarities. Okay. So this is VR1. Drop, rise or drop? I'm sorry, that's negative, ya shabab. Negative. Minus VR1 minus VR2 plus VS equals 0. So what is VR2? VS minus VR1. What is VS?
BS20.
20 minus VR1. What is the VR1? R1 times I1. It's going to be 20 minus 10 times 1.04. Calculate the answer. You will get 0.32. Same for I240. I already know VR2 equal to VR3 equal to VR4. No need to repeat the KVL. So I just calculate this VR2 divided by this resistance divided by that resistance. We expect I2 to be larger than I3 to be larger than I2. I4. So I4 is smaller than I3 is smaller than I2. Do a KCL around this node, you will find 1.04 equal 0.48 plus 0.32 plus 240. Yes, please. I1 is calculated. I1 is calculated through our equivalent. So if we calculate our equivalent here, and add it to R1 and we calculate all R equivalent, it's the same. يعني when we simplified the circuit, we said this is the circuit, صح? We said this is R1, and we said this is what? R2 parallel with R3 parallel with R4. So I1 is here. So I1 equal Vs divided by R1 plus the parallel combination, R2 parallel with R3 parallel with R4. It is the same current because the combination is in series. Get it? Or we could have said it's like that, R equivalent. These two are the same. Get it? So that's one approach to solve the problem. Another approach, this problem, how to solve it? This problem,
Series, parallel.
so we can say the 2 amps. Okay, we can find the combination. So 10 plus 10 is 20. 20 parallel with 20. 10. نص. If they are the same, نص. اختصار. 10. 10 times 2. 20 volts. So 20 volt here. 20 volt there. Then, what is I1? 20 over 20. What is I2? 20 over 20. And then you see 1 amp, 1 amp. I will leave this for you to solve it. R4 series with R3, parallel with R2, series with R1, you can calculate I1. Get it? Do you want me to solve it? I will solve it. Which problem you want me to solve? Both? C. Let's do C. So C is a current source. What did I tell you about a current source? We do not know its voltage. Right? So the current here is I, S. It gets splitted over 2 resistors equivalent to an R equivalent. What's R equivalent? We said R equivalent is R1 plus R2 in parallel with R3 plus R4. Right? Right? And I told you it's 10 plus 10, 20 in parallel with 20 is going to be 10. So the voltage drop across R equivalent, which is the same as the voltage drop across the current source, forget about the passive sign configuration. I want the voltage here, plus or minus VR equivalent. So VR equivalent equal plus or minus? No, the current enters from the plus. Option 1. Plus IS times R equivalent. So I calculate the VR equivalent. Now, after I calculate VR equivalent, no, it's also for Ohm's law.
دكتور مو كنا قبل شوي نقول انه اذا دروب
I didn't do KVL. That's not a KVL. That's Ohm's law. This one is Ohm's law. I already know IS is 2 amps. I already know R equivalent A to B 10. So what's VR equivalent? 20 volts. So there is a 20 volt here and a 20 volt here. Because he didn't ask about the power. Always see what he's asking. Did I answer your question? I am not doing KVL because we're now mature enough to know if they are in parallel, they have the same voltage. You can do a KVL, but the question is you do not know the voltage drop across current source.
اقصد انه من ناحيه الاشاره لو استخدمنا الكي في ال وعوضنا بالفولتج مكان الفولتج بالاومز الاشاره ايش تكون؟ نعتبرها انه اذا دروب نعتبرها سالب.
Well, if you want to do it, okay, what did I tell you about the current source? You cannot know the voltage, you do not know the voltage drop across it. So no need to do a KVL. This is a current source, it's not a voltage source.
بس ترى انت حليت سي دكتور ما حليت.
حليت بيهم.
I did B, okay, I'm solving B. Now, after I calculate the voltage, it's 20 volt, I can calculate the current. So what is I1? 20 over R1 plus R2. What is I2? 20 over R3 plus R4. And then I can calculate I1 and I2. And that's what's required. I1 and I2. Get it?
When you just say because they are parallel and they are equal,
You can say that.
since they come up.
Yeah, you can say that, but that's not always the case in the exam. I'm not doing KVL in this problem. Now, problem C is another problem. Problem C, what he is asking for is to calculate I1 and I2 and I3. To calculate I1, you get 15 plus 25 in parallel with 40 in series with R1 and divide 30 over R equivalent, you will get I1. To get I2, you need to do a KVL, and that's what we will do now. We did not do a KVL here because we do not know the voltage across the current source, but we're doing a KVL here because we know the voltage drop across the current source. So I'm assuming you already know how to calculate I1, صح? So let's do a KVL around the left loop. Voltage rise, or who wants to be the KVL guy? Turkey. So, where do you want to start? You want to start from here?
Yes.
Let's start from here. Only around this loop. Why we're doing a KVL? Because I know R2, I know R1, I know I1, I know VS. The only missing is I2. Let's do a KVL. Voltage rise or voltage drop?
Right.
Plus VS. Voltage rise or voltage drop? Again, put plus minus here, plus minus there to follow the direction of the current. So this is going to be minus VR1 minus VR2 equals 0. So what is VR2? Is VS minus VR1. What is VS? 30. What is VR1? VR1 is R1 times I1. What is I1?
I1 equal 1.
Is 1. So R1 is V1 times R1. Is there a negative sign for passive sign configuration? No, but there is a negative sign from the KVL.
Let's be I1 R1.
ما نطبق إشارة
Oh yeah, I1.
الأومز.
Well,
أومز لو.
Ohm's law, it already enters from the positive. So in Ohm's law by itself, V equal IR plus.
طب لو
The negative sign that we added here is from the KVL, voltage rise, voltage drop, two separate.
إيه بس طيب لو في الأومز لو لما طبقناها طلعت إنه السالب في سالب يعني سالب اي ار. تصير سالب في سالب.
Yes, if the current enters from the negative, option 3 or option 4, then it'll be minus minus. But I'm not going to confuse you that way now, maybe in the exam, but you're right. Always follow the procedure. 10 times 1, صح?
Yes.
It's going to be
20.
20
40.
volts. Then I can calculate I2. What is I2?
I2 is
I2 equal V2, VR2 over R2, which is 20 over 40. It's going to be half an amp. Do I need to do another KVL here? I already know I1, I already know I2. I3 is going to be what? In equal out. At upper middle node. KCL at upper middle node. What's a KCL? I1 in equal I2 plus I3. So I3 is what? I1 minus I2. And then you will find the answer. So 1 minus half is half. Is this problem clear? This was similar to the checkpoint problem we did. So now you can, multiple methods to solve the checkpoint problem. If I bring you this in the quiz, will you be able to solve it? If I change the numbers, can you solve it?
Yes.
Okay? Okay, things are not going well with our flow, but that's fine. Let me talk about voltage divider and current divider, which is section 2.3. Voltage divider, باختصار, the voltage gets splits across the resistors in series. The voltage gets splits proportionally across the series. So for example, V total is going to be R1 over the summation plus R2 over the summation plus R3 over the summation. That's the formula. If I want to calculate V1 without calculating the current, if the elements are in series, it's going to be R1 over R equivalent times V total. R2, VR2 is going to be R2 over R1 plus R2 plus R3. The VR3, keep in mind, so this is a shortcut formula. I'm not going to derive it, it will take time. But what you need to know is, if I tell you, simple example to voltage divider rule, we call it VDR. If I put a 5 volts here, and I put R1 equal 1, R2 equal 2. So what is VR1 and what is VR2? VR1 is going to be 1 over 1 plus 2 times 5. VR2 equals 2 over 1 plus 2 times 5. In other words, the voltage drop across the bigger resistor will be more. واضح? These formulas, it can be extended to 4 or 5 elements as long as they are in series. For VDR, only for series elements. Why we do VDR? Because why bother we calculate the current every time? Sometimes all what I care about is the voltage drop. Let's do a quick example. This is 15. What is the voltage drop here? Keep in mind that this is a plus minus, plus minus, plus minus, plus minus. If we reverse the polarity, if you put minus and plus, then you have to add a minus sign. But for now, the polarity is consistent. Plus minus, plus minus, plus minus, plus minus. So the answer is, V total is 15. It will be 1 over 1 plus 1 plus 2 plus 6 kilo. So it will be
1.5.
I don't know. Anyone has a calculator? Took your calculator. Anyone has a calculator? Can you please do it?
1.5.
1 over 10 plus 15. 10, 15.
1.5.
So VDR, make sure they are in series. Check. Are they all in series? Check. So V1 equals R1 over R1 plus R2 plus R3 plus R4. It's going to be 1 kilo over 1 kilo plus 1 kilo plus 2 kilo plus 6 kilo. Kilos will cancel. So what will be the answer?
Liter times V total.
Times V total. 0.1?
1.1.
Yeah, 1.5.
1.5?
عدل.
No, it doesn't.
0.1.
0.1. It's going to be 1.5 volts. You keep the same. At the end, if you sum KVL, V total equal V1 plus V2 plus V3, VR3 plus VR4. بمعنى أن also I can calculate VR2 by looking, same as VR1, because they have the same resistor.
Double.
VR3 is going to be twice. Is it going to be twice?
Yes.
I don't know. I'm not sure. Do the math. VR4 is going to be equivalent to this voltage, because this 1 plus 2 is 3. Is the voltage divider rule clear? Whoever wants to leave early, he can leave. Somebody said he has a class. Oh, you can.
هذا بس بالنسبة للإشارات اللي هي البوزيتيف والماينس والمقاومة الجهة اللي يخش منها الكارنت هي البوزيتيف دائما.
What did I tell you? Always, if he doesn't give you a direction of a current, you will say plus, minus, plus, minus, plus, minus, plus, minus. The current, we love the current to enter the positive. المتأخرين, that's the price you're paying for being late. Is you don't get to leave until we finish 10:50. So any question about voltage divider rule? Okay, next time we talk about current divider. We not have enough time for it today. So any question before we finish the lecture? Any question? Still have 2 minutes.
So for the quiz and homework, we can use chapter 2 to solve.
Yeah. If you want to use chapter 2 to solve homework 1, I'm okay with it.
The graders are going to grade not you, right?
Well, the graders are going to grade, but I'm going to have a revision of the grades. Any questions?